In this video, we will be talking about different applications within the 7th layer of the OSI model. First, we have HTTP, the Hypertext Transfer Protocol, which is the standard used for exchanging files on the web. It functions as a request-response protocol in the client-server communication. For example, the client submits an HTTP request message to the server requesting some resources like an HTML file or any other content. Then the server will return a response message to the client, and this response will contain the response status code and also the requested content in its message body. There are also multiple HTTP methods. The two most common methods are GET, which retrieves a requested resource, and POST, which is used to insert data into a resource, like when posting a comment on a web page. There is also the HEAD method, which is similar to GET, where the server will get a request for something, but rather than responding with the message body that includes the requested resource, it will only send the HTTP headers that would be sent if there was a GET request. Generally, it's used to inspect requested resource headers, not the HTML data requested itself. There is also the PUT method, which is used for the server to store the resource sent by the client at a specified location. Like when you upload an image to a website, then it's stored in a folder within the server itself. Then we have the options method, and this is generally used when you want to be certain of the capabilities of a server, like trying to know what methods are enabled on the server. And most servers do not respond to options because it was widely known and considered a security risk. Delete, as the name implies, is used to delete a resource from the server, and trace is used to return the full HTTP request back to the requesting client. So it will just kind of print it back to the client. Next, we have the different versions of HTTP. We have first the HTTP version 0.9, which is the first documented version of HTTP. It only supported GET method and only supported the content in HTML format. Then we had the HTTP version 1.0, which supported HTTP headers, and that allowed many features, with some of them being content encoding or compression, also user agent, which provides details about the software or system used by the user when making the request. It also shows long strings that indicate the version of browser that the user was using. It also allowed the head and post methods. Then there is the HTTP version 1.1, which allowed the rest of the HTTP methods. It also had better performance generally in caching, compression, and other stuff. It also introduced persistent connections, which are also called HTTP keep alives. They allowed multiple requests and responses to be sent and received one after the other over the same persistent TCP connection, rather than having a new connection being established for each request and response. So rather than multiple TCP connections with multiple three-way handshakes, there will be only one TCP connection and one three-way handshake. It also allowed cookies, which provides a way of storing some data related to the state of the client's connection with the server in the client's browser, so that the server can retrieve this data when the client connects to the server again. And it uses the setCookie command to do that. Next, we have the different HTTP status codes that show within the respond. These have different meanings depending on the first number that they start with. The ones that start with number 1 are informational. The ones that start with number 2 are for success. The most common one is the 200 OK, which is for a successful request. Number 3 is for redirection, and most common one is the 302, which is for when the user is redirected to a different URL. And there is also the 4 category, which is for the client-side error. And the most common one is the 404, which is for a page not found or resource does not exist on the server when the client maybe by mistake writes the wrong URL. And finally, there is the 5th category, which starts with number 5 for the server-side error. Next, we have URLs, which are used to identify a location of a resource like a web page within a server. So HTTP URLs are made of multiple components. First, we have the URL protocol scheme. So basically the protocol used may be HTTP or HTTPS. Then we have the domain name or the host name of the server that is hosting this website. And third, we have the URI, which is made of the path, which is the location of the resource that we're trying to access. And the shortest path possible is just a slash, which means that the resource we're looking for is in the root itself. And also a query, which is not required but sometimes shows on the URL to specify what type of content will show on the web page. Here is what an HTTP URL is going to be looking like. In the first example, we have HTTP, and in the second example, we have HTTPS, which is basically the secure version of HTTP that uses SSL to encrypt the data rather than showing it in clear text like HTTP. Then we have the domain name, which is www.library.com in the first example and www.by.com in the second example. Then we have the path to the file we're trying to access. In the first example, it's in the book directory and the file is called filter. And in the second example, we have the shoes directory and all file. Then after that, we have a question mark, which means the beginning of the query. And then we have the key and value of the query. So in the first one, we are looking for the type kids books. And in the second example, we're looking for shoes with the color red. Then we have DNS, the domain name system, which is used to resolve domain names like example.com to an IP address. It was created because when the internet was first developed, it was so small, there was no need for a global DNS service. Instead, every computer had a local text file called hosts, and this file contained a list of names and IP addresses of every host on the network, which was very small. And when a new computer was added, every network administrator had to go and update their version of the file on every host. Then when the internet grew much larger, DNS was used. It works on TCP and UDP port 53, but mostly it uses UDP port 53. DNS also divided the domains to work in a hierarchical structure, which is useful because it allows each domain to be managed separately and will also reduce the risk of having duplicated names since each name will be in a different namespace. For example, here we have these two domain names. Both of them are named hello, but they're not considered a duplicate because each of them is in a different namespace. The first one is in the .com namespace while the other is in the .org namespace. Now we will look at how DNS works. So first we have this example.net. Let's say there is a user that tried to browse this page. First, the local DNS resolver checks the local DNS cache for a previously resolved match. If there is no match, a request will be sent to a DNS server. If the name we're looking for is a local domain name and the DNS server is responsible for it, then it can resolve it. But in most cases, like when browsing the internet, the DNS server will generate a new request and send it to the root DNS server. Then the root DNS will look in its record of top-level domains. For example, here we have the .com for commercial organizations. We have .org for the non-commercial organizations like charities. .net for network-related or general-purpose organizations. There are also more like the .gov for government institutes and other things. But in our example, it's .net. So the root server will send back to the original name server the IP address of the .net name server. Then the user DNS server will again send another request to the .net name server asking for the IP address of example.net. Then the .net name server will look in its records for the requested second level domain, which is example, and when it's found, it will send the IP address to the original DNS server, which will also give it back to the local DNS resolver. The resolver then stores this new record in the computer's local DNS cache for a short time to speed up the process next time the computer tries to access the same domain name again. There are also multiple types of DNS records. First, we have the A record, which is the host record. It's a name to an address record that will change the DNS name to an IP address. Then there is the CNAME record, which is used to create an alternative name or an alias for a host A record. For example, you might have a server which already have an A record with the name of server2.example.com. You can create a CNAME record called www.example.com, and then both records will be using or pointing to the same IP address. This way, it doesn't matter which name is used, it will all direct to the same server. Next, we have the SOA or Start of Authority record, and this one is used to indicate the DNS server, which is the source of information regarding the zone, basically the authoritative DNS server, and there can only be one per zone. We also have the NS record or the name server record, which represents the DNS servers within the zone. There can be multiple NS records for multiple DNS servers like the primary and secondary DNS servers, and each of these DNS servers will have its own NS record. There is also the MX or mail exchanger record, which represents a host like a server that can handle the email traffic related to the domain, like a mail server. Also a PTR record or a pointer, which is the opposite of an A record. So rather than having a domain name mapped to an IP address, here we have an IP address pointing to a domain name, basically a reverse lookup. Then next we have the next application, which is FTP or File Transfer Protocol, which is used to transfer files from one system to another. Those two systems can be on the same or different networks, and often one of them is remote. And because this is about file transferring, where it is very important that the receiving computer receives the correct data without any errors, FTP uses TCP on port 20 and 21. So when the client first connects to the FTP server, it uses TCP port 21 to establish the connection. Then when the computer sends or receives a file from the FTP server, a separate connection is opened on port 20 to exchange the file. And there are two types of FTP. There is the active FTP and the passive FTP. First, we will be looking at the active FTP. So in an active FTP, the first thing that's going to happen is that the client will do an initial connection to the FTP server, with the destination port being 21, and the source port is going to be any random port number from the client. Then the server will respond to the client with the destination port being the client's port number and the source port being 21. Again, the server will initiate the data connection. So the source will be port 20 and the destination port, it will be the port of the client. And then again, the client will respond to the data connection on port 20 being the destination and the source port being any port number from the client. But active FTP is not used a lot because the client is not the one responsible for establishing the data connection. It is initiated by the server, and the client only tells the FTP server what port it is listening on and expects the server to open the connection. Because this second connection is a new outbound session, the firewalls or any other security devices may consider the connection as an unwanted or hostile connection and it will be blocked. So passive FTP starts the same way with the initial connection. It starts from the client and then the server will respond. But when we come to the data connection, it will be initiated by the client. And then this FTP server will be responding to that. So in passive mode, the client initiates both connections to the server, which solves the firewall issue. Next, we have the Session Initiation Protocol, which is used for voice and video calls over IP. It is mainly used to set up and terminate sessions, typically used in TCP and UDP port 5060 and 5061 if it's secured with TLS. Now we have the Simple Mail Transfer Protocol or SMTP, which is used to transfer emails, and it can send emails between a client and a server, or a server and another server. Transferring emails also need reliability, so it uses TCP on port 25, and SMTP also have a 3-digit response codes that come with the reply messages of the receiving party. The first group that starts with number 1 are success messages, but they mean that there's a success but requires confirmation. The second group that starts with number 2 is for a complete success, which is the most commonly seen one. And then we have the third group for success, but there is a more input expected. And we have the fourth, which is for a temporary failure. And the last fifth group, which is for a permanent failure.